Right, testing. Sorted, we have sound. Let's get the system up. Here we are. Today is Metal Rogue, because we're going to be using metal. Interesting. Okay, let's see if we can do this. So that's my sandbox. Oh, getting dinglings. What are me dinglings for? Stop it, you. Dinglinging at me. Let me just check. What the heck's going on? Alright. That helps, doesn't it? Yeah. Let's put the right stream up. Yes, folks, we started with the wrong thing. As usual. Nothing there. Okay. Yeah, looking good. Let's say hello. There we go. Hope Seppies are having a better time today. Let's try that. Yeah, that seemed to work. Yeah. Oof, blank. macOS. Playground. Cancel. No, thank you. Let's try again. Xcode project. Thank you very much. An application. macOS. Top. Yeah, looks good to me. Let's try one of them. Product name. Metal. Underscore. R-O-G-U-E. Rogue. Looks okay. Swift storyboard. Don't really care what you do to me. Looks good. Just create it wherever. Thanks, that'll do. Blah de blah de blah. Okay. Let's add some metal. So, metal framework. Let's add some more metal. Metal kit. Another dingling. Hello there. Whoever's dingling at me. And we'll have shaders as well. Looks good to me. Yeah, that looks okay. .3. Why do I want it 9.3 compatible? Class prefix none. Spaces and tabs. Okay. Development access, sign-in capabilities, non-resource tags, don't care. Info, build settings, yeah. Whatever. Whatever you want. I want to go to the storyboard. And under view controller, view, I think yeah, here we go. I'll have MTK view. Yeah, it comes up for me. Thank you. Identity, whatever. So I think that's about all I need to do to start off with. That just makes sure that it knows that we're going to be using metal for this view. Size of the view, yes, good point. I want 900 by 500. Want my standard sizing, please. There we go. Auto sizing doesn't matter for this part anyway. And now we can run. Build succeeded. Make sure our window's correct. It is. There's our window. That's SDL out the window, literally. That is a metal window. Wow. View controller. I think that's where we're going to be. Yeah, we'll go here. All right. There we go. Lovely. Get rid of that. That looks okay. For now. Let's see what we can find. Search metal. This is developer.apple.com. Okay. Games that render sophisticated 3D environments. Why, hey. Use Metal Kit to simplify the task of getting your metal content on screen. Use Metal Performance Shaders to implement custom rendering. So, basic tasks and concepts. Okay, let's do that then. Essentials. These sample code projects teach fundamental concepts used in Metal apps. Each project builds on the previous project, so work through them in the sequence shown. Have I got this set to Swift? No idea. Okay. Let's see what Metal can do. So I guess we're starting at the top. To find GPUs and perform calculations on them. Download. What do I want to download? No idea. Okay. In this sample, you'll learn essential. I don't know why I've got a download button here. It doesn't say why, so hey ho. This says Xcode 11.3 plus. We'll go to 11.4 then. That's as far as I can go up, so I'm guessing that's that. Okay. You'll see how to convert a simple function written in C to Metal Shading Language, MSL, so that it can be run on a GPU. That's going to be helpful because I need some C. You'll find a GPU. Prepare the MSL function to run on it by creating a pipeline and create data objects accessible to the GPU. So what's this download do? Allow. Okay. Still don't know what it did. Does that mean I've now got to come out of this view? Or can I just press that button? No, it means I've got to come out of this view. Alright, so let's see what they've got here. Metal Compute Basic. Alright. Well, what's their configuration? Sample code. Alright. Okay, we'll keep that to one side then. To execute pipeline against your data, create a command buffer, write commands into it, and commit the buffer to a command queue. Metal sends the commands to the GPU to be executed. Elements of two arrays together, writing results to a third array. Listing 1 shows the function that performs this calculation on the CPU, written in C. It loops over the index, calculating one value per iteration of the loop. MSL. What the hell is MSL? Swift, maybe? Oh, shader in MSL. Shader language. SL. Got ya. Metal shader language. MSL. Gotcha. MSL is a variant of C++. That's correct. It is. Alright, there's nothing here. Find a GPU. Oh, right. So we've actually got to the stage where we get to a device. Initialize metal objects. Okay. Get a reference to a metal function. Okay, here's loading shader files. In the project, okay. Alright, I think we can do better than that. Prepare a metal pipeline. MTL compute pipeline state. I don't want a compute pipeline. Create a command queue. Create data buffers and load data. Okay, yeah, that looks okay. Create command buffer. Create command encoder. And voila, you have it all. Set it all up and say run. How about that? Thread count and organization. Fantastic. Encode the compute command to execute the threads. Yeah. End the compute pass. Yeah. Wait for it to complete. Yeah. Sounds very familiar to Vulkan. That's definitely a Vulkanese. Read the results from the buffer. That's exactly how Vulkan would do it. Okay. Rendering graphics content with Metal. You'll use the MetalKit framework to create a view, which we've done. Then you'll encode commands for a render pass that erases the view to a background color. That's exactly what we want. MetalKit automates windowing system tasks, loads textures and handles 3D model data. That's nice of it. Yeah, we will do, probably. Prepare a MetalKit view to draw, which is a subclass of NSView in macOS U. Yeah, so I've already done that. MTK view. Delegate details, yeah. Needs a reference to a metal device object in order to create resources internally. So we're going to have a view.device, are we? The first step is to set the view's device property to an existing MTL device. Okay, what I'm going to do is open my sandbox. Because in here, I've already prepared a load of stuff. That one there. I want to have a look at what I've done compared to what they're telling me to do. TextEdit will do. Right. Alright, so I also see that they don't say anything about imports. So they mention this metal view thingy. Don't tell you what to do with it. It's this MTK view. And they've mentioned nothing about any kind of imports. Ew. This is going to be fun. By the looks of it. So I'll use mine instead of theirs, I think. What we'll do is you'll pop you over here. Let's have a look. So they're talking about a device. Right, let's work out how to make a device. Oh, this is still in full screen, is it? You'll have to come out of full screen, mate. There's no way we can have you in there. Okay, that'll do. Alright, so first of all I will import MetalKit. That's the first thing I'm going to do. MetalKit. There it is. If it keeps coming up with errors, don't worry about them. We don't care about errors here. First of all, let's just make sure that we are running. Yeah, we are. Okay. Stop any kind of run going on. And now they want a view. So we've got a class view controller. NSView controller. If I can get this scroll wheel to work. So we now have this conversion going on here called metal view. I think that's what they're talking about here. View.device, maybe not. This is not useful. Main entry, here we go. So they're talking about this line here. All right. Let's try it. Where can we put it? Override function view did load. Override var represented object any did set update the view if already loaded. I'll keep you. Do any additional setup after loading the view. Okay. End of view did load. So this is view did load. So we're declaring metal view in view did load, but we haven't got the variable. So if I try to copy that into here, actually we can put it here, can't we? End goes downwards, great, not to the end of the line. So if I put that in here, what's going to happen? It will accept it. Nope, unresolved identifier, as expected. I can see we're going to get far with these instructions. This is the manual, remember, from Apple. What we're missing is that. And that goes outside of view did load in here. Oh, control doesn't work. There we go. Gets rid of the error. Well, this is started well. Other properties on MTK View allow you to control its behavior. To erase the contents of the view to a solid background color, you set its clear color property. You create the color using MTL clear color make. Yeah, why have you got colons there and commas here? Me no sure. So we can try putting that in. It's RGB alpha. Alright, let's go and see what I put in here. Main entry. Right, I'll do their version. I think I like their version better. I don't think my version looks very good. Copy. And let's add it. Now this is Swift, so there's no semicolons. It's C++ without semicolons. If you think of it like that, I think you'll go all right. So we'll take our metal view. So far, there's nothing that isn't OpenGL here. Dots. And it comes up with a list. So this is our clear color. And that equals whatever I've got here. I'll put you back down to 0.1. 5, no. Put you at 0.1 for a second, and you at 0.1 for a second, and we'll have RG, we'll have blue, 50%. That'll look alright. Lovely. Anybody who's seen my stuff before will know why I leave 0.1s in there, because we use lighting, which I'll probably be doing on this system. So that's how you clear a colour. Interesting. Because you won't be drawing animated content in this sample, configure the view so that it only draws when the contents need to be updated, such as when the view changes shape. View enable set needs display equals yes. Alright, I'm going to follow through with what I've decided to do here. So I don't know where to put it, so I'm guessing it's here. Because this is where we're doing all our metal view stuff. Metal view dot enable set needs display. Alright, let's try enable to start off with. Enable. That's the only thing there, so let's do it. Equals. There isn't a yes. Why are these people putting semicolons at the end? Language Swift. I have no idea why they're putting semicolons at the end. What language are they in? Okay, crazy people. These are crazy people. They're telling me about metal with semicolons and I'm in Swift, language Swift. It says it there, at the top. Yes doesn't exist. Cannot assign value of type object C bool to type bool. Oh, well, true then. Try true. That's bool. There you go. Delegate drawing responsibilities. MTK View relies on your app to issue commands to Metal to produce visual content. MTK View uses the delegate pattern. Now, delegate is a word that I see come up a couple of times in this Apple stuff. What it means is override. It's an inheritance device which you use in C++, which I've virtual, I think, is the word that I would use, not delegate. So we need to override the view's virtual properties. So view.delegate equals renderer. Okay. And we are going to implement two methods from it. At this point, I have to stop and research this renderer thingy, because this isn't exactly telling me what to do. It's just saying this is, like, in general, what you do. Right. Delegates. I know a bit about delegates. I'm not too bothered about that side of it. It's this view.delegate equals renderer. Whereas here I've put metal view.delegate equals self because I've put the delegate below here. Okay. No, that's no good to me. There is a file on here that might be good to me. Let's try in here. Let's have a look at you. Projects, final, playground, no good to me. How's about rendering pipeline? Renderer.swift. That's what I wanted to look at. So let's have a look at view controller .swift first. Because I think they'll do it that way. No idea about that. Var renderer. Renderer equals renderer, metal view. Well, that's about as helpful as kicking the teeth. That looks sensible. There you go. MTK view delegate. I think I would prefer to do it that way. I'm not sure what this is telling me to do because it's got a semicolon at the end. Object that confirms the MTK view delegate. Yeah, that's good. So I think I'm going to go with this renderer. I'm going to call it rendering because I don't know how to pronounce render. We'll have a class. Rendering. Yeah, I can go with this. So Metal Rogue. Showing folder. No, I want a folder. New group. And we will call this source. And then within source, new group, metal. And in metal, why are these going down the chain? I will have a new file. It will be a Swift file. Belonging to Metal Rogue, and the file will be called rendering. Because I know how to pronounce that, and it makes more sense. Create. Oh good, it has gone down the right path, that's fine. Whew. Right, so rendering. What exactly are we going to be placing in a rendering? Let's have a look. Import metal kit. Class rendering NS object. Okay, let's pop you over here then for a second. I'll need you in a second or two, so we'll pop you just above it. Right, so yeah, this is research, isn't it? This is why I have delayed this a while, because all of the information I could find is either out of date or non-specific, as you can tell. So what we're going to do here is we are going to import metal kit. Do we need the foundation? No. Okay, import metal kit. Class rendering. This colon means give me a it's a bit like C++, it's inheritance. That's what the colon's for. NS object. I don't know what NS stands for, but it's, there we go. It's an object, this. So let's have an object. Comes up in a pretty colour, so I'm happy. There we go. And then it makes some variables. So init variables. I'm not going to worry about those too much right now. And we have to put this next bit in because it's got guard and it's also an initializer. This is your constructor. Alright, if you're from C++ or C or whatever, this is your constructor. It's called init. That's all. So we're going to initialize or construct our metal view. Metal. I'm going to call it underscore view. Because because that's a variable. MTK view. That's what we used, if you remember, for our window. And we are going to ask this thing to guard. GUARD condition. And an else. Now this is now telling me, alright, I don't want all this rubbish in. Thank you. Thank you very much. We'll come to you in a bit. Alright, just get rid of you. Now this is where it's telling me that I should have my variable device. So let's go get my variable device from here. We'll cut the U and we're going to pop you into rendering here. Okay. I don't like the way these are all over the goddamn shop. So all of this lot now has to come out of here. So we're going to have to cut you and we are going to place you in rendering. Should I guard the lot? I don't think so. Expected else after guard. Yes, I know you do. It's here. So we have static var device. Okay, let's make you static. Means it's only global to this object. You also want a command queue. I don't think we've got that far. Yeah, this is not looking correct. It's that there that's bothering me here, this device. It's setting it as a variable and then setting it as a constant. Is that correct? Oh, it's in the initializer, it doesn't matter. Yes, you can do that. Which one is correct? I think we can take this out and we can use theirs. MTL device. There it is. And you do need the pling at the end because that means force conversion or type defit or whatever you want to call it, or I don't know what to call it. Expected else after guard. I've got to go right down to the bloody bottom to find this, haven't I? There's command stuff. These have commas after them. Is that correct? Yes, it is. Come here. I want a comma. Why have I got a semicolon here? Comma. Use of equals in a Boolean context. Ah, you... Yeah, okay, let's get rid of you. I'm not exactly sure what you're doing, mate. Oh, wait a minute, no. That's fine. Let's get this correct now. So, let. Let. And let. Alright, we're okay now. I can pull my else back. Fantastic. What shall... what MTL device cannot be used as a type conforming to protocol? Equatable, because equatable has static requirements. I thought I put static there. Oh, don't start doing this to me. It really does not deserve to be a language, this. Alright, let's go with this. Let's go through this slowly now and get it correct. Right, I can't do these things here. That's fine. Throw away these for a minute. It's not liking this. I don't blame it. Where can I put it? just pop you out of the way, please. For a second, whilst I work out what the hell to do with you. Alrighty, so we have a device. It's not Metal View, it's a device. Let's call it device then. Okay. Now it's been talking about Metal View, so where's your Metal View? Metal View is here. Okay. Else statements, yeah. What do we got? Rendering.device. Rendering dot metal device equals metal device. Doesn't look right. That looks right. Now we've got an error. Is not usable in its body. God, I wish they wouldn't use the same names all over the place when I'm trying to decipher what the hell they've done. Maybe it is metal. No. This makes no sense to me whatsoever. There are two devices in here. There are two separate device methods here. Okay. This is a bit baffling. let's have a look at my previous stuff here. A lot of it thrown away. Building a pipeline. Yeah. View did load. This is where we're finding our cock up. Guard body must not fall through. Consider using a return or throw to exit the scope. Okay. What the hell, why not? This is error checking. Right, let's see what else we've got in here. We've got init, metal view, MTK view. Just get a load of guff. Some kind of mesh going on. Pipeline descriptor. And then they put metal view dot delegate equals self at the point there, and they bring it in here under the extension MTK view delegate. So what I'm seeing here is exactly what I've done before, except init is this part here. There's the super command. So it's this. Alright. You, go away. I've had enough of you already. You can get lost. You can get lost. Let's work my way. Godfathers. Yeah, that's where it should be. Right. Right, it says static can't be done that way. Easy. Easy to solve. Just go away. I've already had enough of that. So this is the initializer or constructor of metal view. So now I can do that without the comma, please. Now we don't have problems. I like it when I don't have problems. Right. That's nice. Right, so if we've put that in there, we need to be able to call it from view controller. All right, let's try and get this from view controller now. All right, so variable metal rendering is rendering. Don't need to import it. No. It's happy with that, I hope. And it has a question mark because it needs to have a question mark. It can throw. It can fail. Great. Override function view did load. Super view did load. Yeah. Right, this is where this view as thingy comes in that I was using. Okay. I think we can do that. Alright, so view did load, we have to put this gumph in here. Let's try it. Okay. It doesn't seem to care about this. Yes, it does. Good. Metal. Rendering. Equals that. Fatal error. Incorrect argument label in call. Why? Right, let's try doing it my way. I don't think this guard is necessary. Why has it got this rendering like this? That's a variable. We are setting it to that. Why do we need another variable? Where's metal view come from? What is this rubbish? What? Yink. Seriously? That's what you wanted? How does my rendering receive that? That's what I'm more worried about. I mean, we're sending in a variable here, aren't we? No, we're not. Yeah, it's here. Then this should be okay. Okay, I think we're nearly there. The window's changed. Never mind. I'll come back to that. That seems to be working. For absolutely no reason that I can give. Oh God, let's do this. All right. So that's some kind of garbage stuff here. All right, so this we can mark as what can we mark it as? Main entry point. That's main. And all it's going to do is say, go over and do some rendering. What about the delegate side of things? It's a good question. Doesn't seem to care. Alright, so we've got our super init to do. And then our delegation to do. The delegate will be the one that is the game loop as such, I suppose. Okay. I don't see why I want my main game loop to be in the renderer. I'll mark this one as well. This will be initialization. There we go. It just comes up as a little marker up here on me thingy, so I can find things later on. Right, so according to me, we are in the right place to do a delegate. Is that what it's telling us to do? MTK view draw sizable window change and draw. Okay. Hello, Muppet. We're going to make a delegate. Isn't that nice? I want it from this one, please. Right. So here we have the clear colour and the delegate. Right, good. So super init before the clear colour. Yeah, that sounds fine. You can do it anytime you want, really, can't you? I'm not sure. So yeah, we will do super. Dot init. And then we'll do the clear color and whatever that does. And then we just want metal view delegate self. Delegate. Is it equal? Yeah. Equal self. What that means now is that we need to write the delegate, the extension. Cannot assign value of type rendering to type MTK view delegate. I've initialized it as an MTK view, so why not? I don't trust you. I've got to that stage now where I don't trust the language. Let's try it. Extension. Because I think it's right, you know. Of rendering. And that is an MTK view delegate, which it's saying I can't have. An MTK view delegate, second one. Oh, now it's shut up about it. I see. Let's open the brackets then and see what we can do. So what do we need? We need two. We need MTK view and draw. Okay. We'll have that then. So func. and it's MTK view. At this point I'm going to do what I'm told and use that. Open brackets. And it's underscore, which means leave blank. Then we have the view, which we are going to set to MTK view. What else we need? Drawable size will change. It's not coming up with anything. Fine. Size will change. I might spell that wrong. And then it's size. CG size. Okay. And they're not putting anything in there. Why aren't we doing our aspect ratio in there? Whatever. And then we just need the func draw. Func draw. And then it's in view. Colon MTK view. And we'll come to that later. Is it complaining still? No. Are these view colons supposed to be metal view? Well, no, it's certainly not complaining. No, it's certainly not complaining, and we do have the Metal API validation enabled, which says to me this is Vulkan. Vulkan made to look like OpenGL, wow. That's progress. I think I'm happy with that. I'm happy with that, and I've got cold coffee. So I've done what it's told me to, in a roundabout way. You might notice I do change the wording, like my variables to mean something, instead of the cobblers that they seem to be giving here. I mean, what's that? Enable set needs display. I don't know. Right, we're trying to clear the colour, aren't we? We've got a colour, blue. AAPL renderer implements the delegate methods and takes on the responsibility of drawing. Really? Does it? The view controller creates an instance of this class and sets it as the views delegate. Good for you. I'm happy for you. When you draw, the GPU stores the results into textures. Does it now? Which are blocks of memory. Well, they're not textures. Which are blocks of memory that contain image data and are accessible to the GPU. In this sample, the MTK view creates all of the textures you need to draw into the view. It creates multiple textures so that it can display the contents of one texture while you render into another. So what you're telling me is there's two buffers, there's a back buffer, there's a front buffer, and you're going to swap them. Don't tell me the textures, please. They're just blocks of memory. To draw, you create a render pass, which is a sequence of rendering commands that draw into a set of buffers. When used in a render pass, buffers are also called render targets. Good, let's rename what you've already renamed. To create a render pass, you need a render pass descriptor, an instance of MTL render pass descriptor. In this sample, rather than configure your own render pass descriptor, ask the MetalKit view to create one for you. For starters, you've just made that into a pointer. Then you've got a semicolon. Great. Got to feckin' decipher this now. And this is using some kind of guarding mechanism again. Without an else. Oh yeah, we do have an else. But it won't like it dropping through. Ah, there's a return. That's the same as doing if return. They use guard return. I like this. I like this. This is okay. So I'm going to take the full block. I think that's okay. Let's have a look at what I did. That's your main entry point. Because I know I cut this right down. View delegate. Here we go. I've just renamed stuff. Right, that's coming from external, that's coming from external, and this descriptor is the only thing that we're really caring about right now. I'm going to go with this. Let's see if that'll hold up. This is going in the draw call. Okay, copy you over to there. And we'll have you as rendering. Okay, that looks okay. Alright, well we haven't got up to that bit, so we'll just take it out. How's about that? Goodbye. You are the weakest link. Use of unresolved identifier command buffer. Yeah, okay. I agree. Goodbye. Alright, so that says else, return. Okay. Yeah, no descriptors never used, thank you. Just putting this guard correct. No, I'll keep it as was. Right, we'll keep it as that. Alrighty, so we've now got ourselves a descriptor, and it's accepted it. That's even better. Okay. You create the render pass by encoding it into the command buffer. Really? Pray tell, where do I get a command buffer from? Command Q underscore GPU. There we go. I'll take U as a variable. And we'll pop you at the top with all the rest of the variables. So there's our command queue. Lovely, which means we can have a command buffer. What is the difference between a dead Yankee and a dead squirrel on the street? Oh, I don't know this one, Seppi. I know I can't say the answer as well. Go on, Seppi. Let us know. You see breaking marks in front of the squirrel. Nice one, nice one, nice one, nice one. You don't like Yankees, do you? Ah, oh, bless. Oh dear. Let's have one of those lines there. And we will place that in here. Da 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 da. There. Unresolved identifier. Device.gpu. Let's try metal device then. Does that look any better? Yes, it does. Good. I'm getting good at this game. Today's game is how to do metal on the Mac OS. Oh my god. We're actually putting together a rendering thing. I suppose class. Right, so we've done our guard. We're somewhere about here. Let's go down and find out what I did. Pipeline. And that's building a pipeline state. I'm not bothered with that. Somewhere down at the bottom here, we should let command buffer equal. Yeah, I remember now. So let our command buffer equal our command queue. Keep tapping, please. Dot make command buffer. There we go. It's that easy, folks, to make a command buffer. You just have to have a command queue already set up for you. So you make a command queue and then you make a command buffer from it. You can have quite a few command buffers if you want. Don't have to stop at one. So you've done render past descriptor here, and now you're doing a command encoder here. Well, the command encoder is a part of the command buffer. And we don't have a descriptor for it. Okay, pedal back. Where's our descriptor? We create our descriptor in a different function altogether. That's pipeline state. Okay, let's see what I've got here for descriptor. Device command queue, yeah, I've got those two now. I have no descriptor. How is descriptor created? Right, the descriptor is created out of everything else by the looks of this. So you build up a pipeline state. I think we're going to have that there. Because we have to unwrap these variables for access, so yeah, we'll do that then. Alright, let's see if this will work. So, comma, return, tab, and V. Right, definition conflicts with what? With previous value. Alright, so I've already done it. Oh god, what am I doing? I can't even read my own. What I've done. So we do have a descriptor. Right, okay. So let's try putting this together now. So we've got the command buffer. We now need a command encoder, which uses the descriptor. All right. Command buffer, yeah. Make command encoder descriptor, yeah. We're okay with that one. Good. Create a render pass. Command encoder, end encoding. Okay. Alright, so you can set the render pipeline state at this point, but we don't have one. Unless you want to give me one. Present a drawable to the screen. Okay. Present a drawable to the screen. Ah. So that's you. What's a drawable? Didn't I have that before? Yes. Alright, let's see what happens when I plonk these two in. No there we go. Unresolved identifier drawable. Have you told us what a drawable is? A drawable is an MTL drawable equals view dot current drawable. Okay. Where did I define that then? I don't see it. I know how to define it, just where? I would say in initialization. Let's try the initialization then, because it's not in here. It's not in there. Gauche, gauche. There's parts of metal view. No, you're not going to tell me, are you? Maybe you will. Submesh, blah 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 blah. Present drawable. And commit. Automatically creates drawable objects to manage its textures. Read the current drawable property to get the drawable that owns. Yeah. Okay. It's this word here that's stopping me. Do you do anything up here for it? It seems to not care. This is a little bit weird. Ah, here we go. Let drawable equal current view drawable. Alright, so that's right down at the bottom. I did a draw call. Ah, it's this draw call here. Alright. But they put a guard on it. Oh, for God's sake. Do you have to? Seriously? This is one thing that I don't understand about this language is why on earth are we double checking it, the language? I mean, it's not our code, so why are we putting guards in? End encoding, we create our drawable and then present. Metal view, please. What? It's the wrong drawable, people. Say what? Oh dear. CA metal drawable does not conform to expected type MTL drawable. Really? What do you want me to do about that? Equals metal view dot. Auto resize. We need an MTL drawable. We don't have one. So it's asking for something I can't provide. That's the best I can do. Used before initialized. Seriously. Where the hell did I place this then? You've got to have that ability from somewhere. So I'm looking for a let drawable. It should all be I sort of grouped everything together, I thought, properly. Model constants. This is amazing. At no point do I say let drawable. Oh yes I do. Guard. It is. But I've put it right up at the top. So something's lying to me somewhere. I've put it in the guard. Here. Let drawable equal metal view dot current drawable, comma, I don't understand why that needs, well, it's unwrapping. I know what that means. It's just saying that we've got a constant that we need to get sorted out. Not sure I'm happy with that line, because that would mean that I should have predefined that either in a static fashion or non-static fashion if it's been unwrapped. So I should have a variation of it somewhere else, if that's how this language works. Which it doesn't seem to in this case. Okay. Alright, I think I'm happy with that then. Okay, let's assume that I'm happy with that. And commit, yeah, I think that's the last thing we haven't done. Yeah, it will be. That's interesting because I've now completely unanchored the rendering. Yeah, it was that guard thing does something. It unwraps. That guard thing does something more than just if equals null. It does a bit more behind the scenes than I thought it might do. That's okay. So I'll just take our command buffer and commit it. Nope, you still got the wrong one. And it's just question mark dot commit. That's it. That's the program. Blue screen or not to blue screen? That is the question. Not to blue screen. Well, that was interesting. Now, I don't even know if this code's being run. That's sad, isn't it? It isn't. We haven't asked it to be run, have we? No, we haven't. Nope, we haven't asked it to be run, is the answer. And it doesn't seem to do it here either. I don't understand this. That to me doesn't seem right. I mean, I would think there's no init. What happened to the init? I don't understand. Metal rendering equals rendering blah de blah. Does that run that code or not? Doesn't seem to. Initialization. View debugging. Oh god, how does this work? Okay. Fine. Press play and see what happens. Okay. Metal API. Why are you showing me this? Allocating init. Well, that's why I asked you to stop, but why have you put me into this code? Oh god. Why me? Why today? Well, I don't see anything wrong with it then if it's got to init. Seems to be getting to there. Does it ever get to commit? No, it doesn't. Where do you put function draw? Good question. Okay. I can see what I've done. That's in the wrong place. Mm-hmm. I'm not sure this is in the right place either. I don't even see a command queue here. Mm-hmm. There's your command buffer. Make render, yeah. This is annoying. Ah. Make command buffer is different. Okay. Let's try putting it in here. Right, but they're not using that. They're using the rendering version. Okay. So at this point they are taking it from the rendering command queue. Okay. And it's saying, no, you can't. Why is that? Oh. No, no, we can't. Right, okay. Instance member command queue GPU cannot be used on type rendering. Did you mean to use a value of this type instead? What type? There's something wrong here. That is the correct command. But now we can't use it. Optional chaining. Interesting. That removes all our query marks, which is optional chaining. Very interesting. I wonder if that's why they put this one in the guard as well. This to me is very strange as a language, I must admit. Stop. It's certainly not getting here. I'll put you up here for now. Draw, I suppose. It seems to be getting to here. But then it's not running this, I don't think. Let's try that. Oh, we've got a breakpoint. Yay. Fantastic. So where do you go next? You go back to NS View Controller. Okay. Thanks. So what are you actually running at this point? This is not my code. I've just realized. This is a spin lock. It's spin locking on metal on that spot. So there is a rendering draw value. Okay. We need to draw though. If it doesn't draw, it's useless. MTK view. Extension rendering MTK view delegate. Why does that not ring right? Mm-hmm. Okay, it's just I wrote it differently there. We have a pipeline state. Should just pick up on that. I don't understand why we're not going there. Do I actually have to call draw? Previously, what did we do to get this running? Okay, we had the init. So this is your init, which view did load. Super.view did load, okay. Delegate equals self. Build model. Build pipeline. Nothing else is done. Je ne comprends pas. Okay. I don't think the answers are there. That's fine. It could be in here for the answer. And it would be in that there. Try it. We can try it. No, gives me even less. I'm understanding this a bit better now. Okay. Let's have a look at that in more detail. Alright, well for starters I've got extra code that isn't needed. So get rid of you. We have that and that. I don't think I need that. I think that we're okay. Super deload, blah blah blah. Keep this as simple as possible. That's exactly the same as we have here. Why won't you work? And where do you go to? You're gonna spin lock on me. Hey, what's this? Metal Rogue, what about you? Why are you plinging at me? Stop doing that. You dumbass. I don't understand that. Okay, I'll call it directly then. Rendering dot draw. and that will be metal rendering. Unused function. Yes, I know it resolves to an unused function, you prat. That's what I'm trying to do it for. God. Metal rendering. I don't know. Try it. See what happens. Oh, for God's sake. Okay. Value of optional type rendering must be unwrapped to value of type rendering. Really? Expression resolves to an unused function. That's because we're trying to use it. Dumbo? Why is it unused? I'm not telling this part that the delegate's over there, am I? I've got way too many uncertainties about this, you know. I really have. Right, there's an easy way of doing this. There really is. What we do is that. So I'll have you two cut. This is why messing around in new programming languages isn't always safe. Alright, let's just pop these in here for a minute. Alright, let's just get rid of you. I want my sand. I want my sand stuff. And I want you. Right, this should have everything I need. Right, let's try this little baby. See what we can do. First things first. Import metal kit, yeah. Did I do that on the other one? Yeah, first thing I did. Right, fine. Alrighty. So we're going to have a metal view, and that's going to be you. I don't give a dingoes what these instructions have said. What I'm going to do is I'm going to build something that works. Stuff them. So I've got a metal view. A metal device. That's a struct. That's a struct. A device, which I've called metal device. Which it really isn't, it's device GPU. Alright. Change its name. Because that's what I'm after. I want the graphics processing unit. Command Q. GPU, yeah. Metal rendering. Sorry, mate, you're just out of it for a minute. You're not part of this no more. You're not working. So yeah, goodbye. You are the weakest link right now. Okay. Alright, and we can get rid of this rubbish that I put in. It doesn't seem to do much. Alright. Anything else I might need? No, that's all I should need. Super, view the load. You're the first instruction. Actually, I'm going to keep that in for once. So this is the 2 lines of code that we're trying to execute. Do we agree? Why have I got that damn thing in it? Alright, let's just pop back into rendering a minute and we'll pick up that. There we go, that'll work. And then we have to enable the extensions. Okay, we'll copy that out. That enables us an extension, which should currently be, oh, you can't do that. Yes, you can. Which is that lot. Copy. Is that where I've gone wrong? I bet it is. No, it's not. Okay, I thought I might have found a mistake. Hey ho. That goes on that line there. There's our extension. And we'll just pop you in there and we're okay. Right. So everything's happy. Except for my legs. All I'm going to do now is try and do what it did before. Right, let's see what we can finish off in here. So, device GPU and command GPU. Those are the only 2 things that we need. That builds a model, that builds a pipeline. Okay. I've got a feeling that metal.view.delegate should have been rendering in there. Don't quote me on that yet. I'm going to look that up tonight. Maybe. I don't know. So there's nothing else required. In here. There's nothing else to run, as it were. Oh, right. Oh, I see. These haven't gone across. Oh, I'll do it properly. Let's get this set up properly. That's better. Alright, yeah, that makes sense. Lovely. So really, it's what I put in rendering here. Present commit. Obviously, I'm trying to do this with the least code possible. Cut, may as well. What it's worth. Right, what did I change name of? Device. Is it used anywhere else? There. Okay. What we got in here that's not happy? You ain't needed. You're not here. You're not here. And you're not here. Do you know Enlo Man Jason? I've not heard of it, to be honest with you. No, definitely not heard of it. Just gone through memory. Well, straight off memory. I know JSON, what a JSON file is, but I don't know what that name is. NIOH man. No, not come across that one. If I have, it hasn't registered in my mind. That's something that's useful anyway. I did look at that other one you were asking about, and I put some notes down to actually do a little bit on that, because it's got some interesting stuff in there. The Google TCP encoding. So, yay, blue window. That's how it's supposed to work. So why can't I just pop that over into a new file? Okay, so it's exactly the same code, just moved into the main file. Okay. So this draw call requires a lot of stuff. I'm gonna work out how to make that class. I don't know how to make a class in Swift by the looks of it. That will be interesting. I'll have a look at that tonight and see if I can. At the moment, it doesn't really matter. That's the basics on how we can just clear the screen. But there seems to be a lot in here. So I've got main entry point and draw at the moment. I don't want to put all of this rubbish in. This is what I'm trying to say. What I would like to do is what we have in the archive. So let's get the archive up. So Sandrogue. What I'm looking to do is to reproduce this, which will be metal for OpenGL. I'm a bit worried about SandMaths. Won't be SandMaths anymore, but it will be. That's going to turn into shader maths. I'm going to put my shader and my maths in there. That'll be interesting. You want me to look that thing up for you, Seppi? I'm going to need a break anyway. Without folder, new group. Oh, it's a JSON library. Am I using JSON? Yeah, I'll look it up. All right. New group. I'm going to call shader maths. Shader underscore maths, because them two I'm going to put into C++. I think I'm not going to be using Swift for that. Bink. Alright, okay, let's try this. NIO H man JSON. JSON for modern C++. You can use JSON files freely with C++ anyway. Qt uses JSON files and XML. Yeah, I totally agree with this. Absolutely. Is it memory efficient? It's about as memory efficient as a programmer that's programming it. Sorry, I'm not going there. Would I use it with the Google stuff? possibly. It would fit in nicely with that. I like this though. I like this idea. This is exactly what I'm going to do to C++ in Swift. I'm going to write out the shader package with all the maths and stuff in there from C++, and I'm going to put something like that into Swift, and it'll do it for me. It'll just make a library out of me C++, to make it embedded. It means that everything's built at the same time, which is okay. I'm happy with that to happen. Just a bit worried about certain things though with libraries. I mean, this is okay to use, but no, there's no buts. This is good to use. Totally. Well done. Nice shout out. Thank you. Thank you. This is a good shout. Well, they thought of everything I can think of. They've got it all in. And they've even got interface compile features for C11. Which is what you need. C++11 is a bit non-existent. C11 is the actual reason for it. C11 changed. This way, where you start to get these smart pointers and things like that emerging out of the code. Yeah. Nice one. I think at some point I will be going into C++. I've got a feeling I'm going to do it on Windows. When I go to Windows for the next stage of development on this game, I think I will be using C++. And then when I go back to Linux for the final stage, I'll still be in C++. I doubt I will go back to C unless I really feel there's a need for it. Linux is for posers. Use BSD. No, thank you. I think the world's... I am using BSD. What are you talking about? What do you think Mac OS is? You muppet. I don't know. I'm on BSD right now. What is my favourite non-Mac BSD? None. I don't use them. This is the first time I've been on BSD. I just treat it as Linux and it just treats me nicely. To be quite honest with you. I do think it's very introverted. I find it difficult to break out of the box in this in this system, as it's built to keep you inside the box. It's all Apple Mac stuff, which is why I'm not using C-Line, by the way. Is because C-Line, does it play nicely with Mac? Yeah. How do you produce a window? I don't know, frigging clue. I still haven't got a clue, and I've got one on screen. I've been looking for the code all over. Where is it? Where's the code for creating a window? I have no idea. But hey, look, I've got an OpenGL or Vulkan or whatever metal window here. A 3D window. Where's that come from? No idea. Xcode says it comes from a storyboard. What kind of language is that? Well, it isn't a language, it's a data set. I don't even know if we can look at it actually as a data set because it's all wrapped up in Apple rubbish. No, we can't. It comes up with this. If you have a look over on this side here, it won't be on that one. If you have a look at Metal Sandbox, for instance, where's the window? Well, it's not in that, that's the Xcode project, that's tests. This is all your garbage. But then there's this thing here, main storyboard. What language is that, everybody? So the storyboard is in a browser. Will you bugger off, cat? Ow. Pudding, that's not funny. So yeah, where's the window? That's my question. XML version 1.0 encoding UTF-8. How many times have I seen that in Qt? It uses exactly the same thing that Qt does to manage its graphical user interface stuff. So there is no window there. The window is being given by a hidden mechanism. I can show it to you. So you won't find anything to do with the window in there. But if you come down to app delegate here, which is an override of a virtual class, you've got application did finish launching. So when you launch, you get an automatic window code on launching. It's coming from the system. The system is creating the window for you in true BSD style. I have very little control over the window. I can size, I suppose, yeah, size, title, and whether it is resizable. That's roughly about it. And I am finding that interesting because it saves a lot of coding, obviously. It also means you don't need SDL2. What I'm really worried about is when I get to doing the networking on here, or trying to do networking on here, how the hell are you supposed to do it when you've got development notes that are so crap? I've never seen anything so bad in my life. But they do give these supposed things. Bye. Which I'm not overly impressed with, but I seem to have worked my way through it, so I don't care. Source control was hard enough to find. It's here. don't know what to say about it. What I'm worried about is that breaking out of this one file is going to really mess up everything. I mean, metal is easy to put in the shader masks and stuff. All I have to do is add a file. A metal file. And guess what it comes up with? Oh look, hash include metal STL standard lib. I mean, how much at home am I with that? A little bit better than Swift, I think. So I don't know what to call this yet. What's happening here? I have no clue. What the hell was that? So I'm messing around with this. I'm getting somewhere with it, but yeah. Let's have a look at BSDs. I don't know. I don't know any good ones. FreeBSD is the only one out there, and that's exactly what the Mac uses. And you asked me for a different one, so I don't know. I'd like to go back to Unix. That's Sun OS and Sun Microsystems is all gone now. There's FreeBSD, OpenBSD, and NetBSD. Dragonfly Darwin. Is Darwin the one that we're using now? I think it is. Yeah, Darwin's the one that we're on. So everybody's nicked it. Yeah, they all use it for the TCP/IP code. That's fine then. PlayStation 3. No wonder it failed. What the hell? That just shows how badly you can make a system. My. I don't like this. The way they all interchange and take bits from each other. All they're doing is adding source code for no reason whatsoever most of the time. But that goes up to 1980, 69. All the way back. So, all came from an unnamed PDP-7 operating system, whatever that was. So the original BSD ends here. That's the end of BSD 4.4. And that's what we're using now. Darwin, yeah. Interesting bit of history there. It's where all the other operating systems came from, or how operating systems developed or evolved. Not necessarily to the good of the user. Only for commercial success were they evolved. Which again is another big problem that I've got with Swift. It's changing literally as we speak. It's a language that is still in development. So by the time you see this, you may not have Swift in this version. This code may not work. As the code I was able to find, or at least research, didn't work at all. Nothing that I researched worked. I've had to do this from scratch. Oh, that line there, super.view did load. That's straight from that silly language. What's its name? Java. That's Java. This var and let system is from Rust. The function system is from Python. And have made it look like C++ with inheritance. So what the hell is this language? I have no idea. Why do they call it Swift? Because it's very easy to program in, funnily enough. But I don't find it readable, as you can tell. So let me try and make this readable for dyslexia. What do we have? We have a view controller, which is badly named because that really should be an MTK view there, not an NS view controller. You should inherit from that. So to me, that's wrong. That's the first thing. Having to do a variable that returns a view. Obviously, view is something that is inherent to the view controller. And we are returning it as an MTK view. Why not just inherit it? Interesting. We then have this colon thing. Now, this system doesn't have types. I can have var x equals 1. And by inference, that will be an integer. But I can have let y equal 2. And then I can put in let z equal x. plus y. And it does something stupid. Why? So all of those commands so far are nearly legal. And we get this. Cannot use instance member X within property initializer. Property initializers run before self is available. How's about that? That is awesome. So you get these very, very strange, mystical help messages. So you can't do that. Also, what it doesn't tell you is X is a variable and Y is a constant. So if I make a variable array 1, whatever, and I make a variable an array 2, what have you got? You actually have consecutive declarations on a line and must be separated by semicolon. Actually, what I'll just do is put a comma in the middle. There you go. Bugger off. So what have I got there? Oh, it still doesn't like it. I've got errors coming out. It's a bit weird, this language. A bit weird. What we've got here is what you would call an array. What we have here is what you would call a vector. That goes like that. It still wants semicolons. What semicolons? You're in the wrong language if you want me to put semicolons in. Sorry. So even defining variables can be difficult at times. Just get rid of this rubbish. So it's one of those very, very weird languages, this. I don't think it's really been totally thought through, but it's pretty much there. The only thing I can really do is put lines between these. All that this bit here does is state that this device underscore GPU has to be of this type. Must be of this type. That's what the pling is about. And I think it's also to do with the fact that they are structs. And we've met the query mark, which we got rid of by putting everything up here. The query mark is a bit weird, I think, because it means it's got options, which I don't know anything about. I don't know what options it's got. You know, nobody wants to tell me what options it's got. So there you go. Excellent. Joy to the world. I think it's quite funny. This is also interesting. It'll do a lot of this kind of stuff, but will it actually do the final? What will it do with that one? Oh, yeah, it does it properly. That's awesome. So it'll do that properly. So it's red, green. So I can actually do my notes properly. And alpha. So this is good. I'm liking this. Still seems to be a bit lengthy across the screen though. There's nothing else there. All of these are hidden commands. So I have no idea what they are doing underneath the hood. I know that's setting the GL clear color. That's about it. These are done normally. I don't like having this else inside. And then it seems to finish without doing anything. It's a bit weird, this guard. See how we put that here, like that. And make that into a guard block. Yep. That to me sounds better, but all that is doing is unwrapping variables so that we can access them within here. Which I also find interesting. But make render commander encoder. What the hell's going on? Current render pass descriptor. Huh. It's amazing. It really is amazing. And this is the simplest program I can do for well, not OpenGL, but Metal itself. There's no if statements. Yeah, there's not one if statement. We haven't made one decision, but these question marks say that we have. So here, at the encoder stage, we've made a decision. Don't know what that decision is. Well, we'll see how this goes, I think. I'm not sure I want to do too much more of this day because I want to look up how to move this. So I'm going to have to look... Oh, thank you, Muppet. That was all over me. That's very kind of you. And I want a bath. So what I'm going to look at next is what we can do with this initial code. Because it's not obvious as to what we should do with this initial code. I find that interesting as well. Okay, let's wrap up. Nearly 2 o'clock. That gives me a good afternoon's worth of research to do. We have now started, for real, Metal Rogue. Let's put it in the start gates here. Use the correct mouse might help. Alrighty. What I am looking to do is I think I want to do the graphical user interface next, but I don't know what's in the archive yet. I will check that and make sure. Let's see what I want to build towards. Line of sight. Lighting. I've got most of the lighting anyway. Max level, stairs down, graphical user interface, and then the backpack. So I think I want to do, for this series, I think I want to do those two. Graphical user interface and backpack. Which will mean that we have to develop the ECS better. So we're going to have ECS, GUI. I don't know why I just did that. Where is source? So graphical user interface is going to be one as well. This new group thingy, I am positive it doesn't put a real how do I rename it? Oh, thank you. Oh, I need a tissue for the keyboard. Okay, let's clean that up a bit. That's good cleaning fluid you sneeze out there, my little one. Graphical user interface. So that's what I'm interested in. What else are we interested in here? I don't know what else we can put in. I'll just put core in case I can't think of anywhere to put something. And we'll call that core. So those are the areas that I want to look at. We're going to have ECS, we'll put that in core. We'll have rendering, which we'll put in metal. We've also got the loading of objects and stuff to put in there. So ECS, metal. Do we need anything else? Not really. I can concentrate more then on this. We're going to need some resources of some kind. So I've got the Sandrogue stuff resource. Let's try that. Yeah, different colour. So that's a real one. These are fictitious, it looks like. Let's find out if I'm right. So yeah, we've got resources. which has my GLSL in and all the models. Yeah, that's good. But under Metal Rogue, we don't have source. Oh, we do have source. Oh, it has come up with real things. Oh, thank God for that. I was getting a bit worried. Right, I'll keep that then. That's good. Click in window, make sure we're stopped. Source control that up. Okay. Yeah, great. Okay. Resources. Anything else, really? Resources with GLSL and models and 3D models. Okay, there's only 83 files. That'll do. So you're in. Good. Anything else I need? Tests? Not yet. Excellent. So I'll keep all of these here, and then I want to start into this source area and find out whether we can get things to work properly like they do here. Like this extension. Very, very dubious about this. Alright, let's wrap that up. 13:55, I need time for food and then research. So I'm off to do that. Hopefully Seppi's going to be researching his MacBSD now and finding out how this Swift works. So I hope somebody does, because I have a basic fundamental idea on how it works, but I can't say that I am enjoying the reading side of this. You can't close a file. Oh, right, close project. Thank you. So my problems here are mainly to do with the manual not being all that helpful, unless I've completely miss what I'm supposed to do here, which is probable with me. Just want to look through something else here. Thank you. Basic tasks and concepts is what we've been trying to do. Alright, this gave us a download. Like that. What do I do with it? It's a project download from the internet. Are you sure you want to open it? Yeah, open, you plonk. Okay, it's got a readme. This seems to be done totally differently. Why is this different? Let's have a look at what view they've got. MTK view. So this is their C version of it, is it? A app. What does AAPLA mean? Or PL? AAPL? Don't know. If target, else if defined target Mac OS. Try run this. It's doing something. Oh. And oh, right. Okay. Okay. Go ahead. What the hell's this all about? Why do I want a telephone on my screen? Okay, they've got a very light blue colour there. Where's the renderer? Oh, it's all the way over here. It's got a header file. God, this looks like a bloody mess. What happened? So there's present current encoding, command encoder. So it's exactly the same. Called whenever the view needs to render a frame. So why have they done that? As you can see, I can't see a clear screen here anyway. Okay, view renderer. There it is. RGB. I should go to that darker blue now. Oh, right, okay. Fair enough. Yeah. That's an interesting idea, but I didn't realise I would be looking at a phone. I guess that this language is their Objective-C. I'm seeing things that are different, like this. That's C. Looks like a very, very broken sea. And there are if statements. Let's have a look at that header file. Import UI kit, app kit, metal kit. Oh dear, I'm going to have fun with this, aren't I? Header for cross-platform view controller. Right, so I'm going to have to look up Swift and find out how the hell it works. That's great. That's really great. Thank you, Apple, for that. What I'm supposed to do with this thing, I don't know. Oh, there's a Hello World thing. That's nice, isn't it? Got my wallet, my news, my calendar. Oh, great, I've got a phone. I'm so proud of that. That's very useful to have a phone on a computer. Yeah. Okay. I'm not going to find the answers in there. That's what I wanted to know. Oh, we got you meowing. So I'm going to go look in other places. I'm going to go reaching across the internet and see what I can find. Got some good ideas of where to find stuff. So I will catch you. No, I'm going to see my wife tomorrow. I will catch you Friday. And we shall progress onwards. By then I'll have a renderer hopefully ready to go. And we shall be able to start on maybe model loading if we're really lucky. I think that would be the next stage, so that we can get a graphical user interface. Now I've left the code for that somewhere else. I'll see if I can find it. I'll dig it out. Take care and enjoy your searches and well, Swift. Try Swift. It's really fun. No idea how to program it, but we'll soon find out. Have fun, peeps.